Good evening, ladies and gentlemen, dear friends of the KITION Planetarium Observatory and colleagues from all around the world, from England, especially from England tonight, yes, and Cyprus. And we have a friend from Ukraine, Alek, Dobre večer. Tonight we have a very special event. It's actually the first officially registered event with a cooperation with our colleague in Greece, Mr. Takis Theodossiou. It's the first officially registered event for the International Asteroid Day, which we usually celebrate on the 30th of June every year. I met Takis through this international project. I am the national coordinator for Cyprus for the Asteroid Day, and Takis Theodossiou is the Greek national coordinator for Asteroid Day. We met through this project. We have exchanged knowledge. We are sharing knowledge. We do projects together. He's helping us because he's the expert in asteroids. He's helping us to anyone who wants to have a collection may buy things from his museum and his collection. So Takis Theodossiou, as I mentioned, he's the national coordinator for Greece for Asteroid Day, and not only he owns the aerolith collection Theodossiou, which became the first museum of meteorites in Greece, and it started 2 years ago, if I'm not mistaken, correct?
Yeah.
2 years ago. I apologize that I didn't manage because of the COVID to come. I will do my best to visit you soon, most probably in the next couple of months as well. As you all know, guys, every 2 weeks we hold the online science cafe sessions. This week is going to be on meteorites. And from next week, we will postpone it 1 hour. We will start at 8 o'clock to be more convenient for our friends in England to join us, as I had a couple of requests. So we are going to do them the favors. It's not going to be late for at 8 o'clock until 9. And in England, it's going to be 2 hours earlier. So they will have the chance to finish work and join us. Because we really have an affiliation with them, and they really support us, and we support them, and we have a good cooperation. So, Mr. Takis Theodossiou, he will give us a talk tonight on meteorites, a very wide subject, and he's going to concentrate, I believe, on his collection, and he's going to mention about things about meteorites in the ancient world, and where we can find. If I'm not mistaken, swords, jewelry, and coins made of meteorites. And I'm really eager to hear about his discovery of the meteorite craters in Greece and about his books. So, welcome, dear friend, Takis. The stage is yours.
George, it's a pleasure to meet you here, and good evening to everybody on the panel. Today, I will be also glad maybe to answer questions, of course, about meteorites and meteoritics and asteroids. So I don't know when to start for, but I wanted to start, as you say, George, from our aerolith collection in our museum. This collection now existing for more than 2.5 years, until the until October, November 2018. We started here with the museum. Then we have worked for about 1.5 years before the COVID situation came. The pandemic. So during all this time, also during the pandemic time, let's say, we were trying to enrich our collection with new, rare, and interesting meteorites, not only for our museum, but also for research reasons, since we are connected with many international institutions that are buying meteorites and buying rare meteorites in order to make research, like Martians, lunars, meteorites from cometary origin, and of course ordinary chondrites as well. So our museum collections have more than 550 meteorites now for the public, but we also possess a number of impactites and impact material from very famous already known craters around the world, meteoritic craters, of course.
Takis, if I may interrupt you for a second, because I would like to apologize for this. I forgot to mention something very important. Mr. Takis is the Vice President of the International Meteorological Collectors Association, and he is also doing examinations about registering meteorites. So it's something very important that you needed to know from the beginning. I really apologize.
Yeah, it's okay, George. I don't keep anything secret, but yes, this is currently maybe the most important, let's say, service that I have to participate by the IMCA as Vice President, now elected for the last 5 months. I was serving, of course, on the board for the last 5 years about. And with this position, of course, I want to try to help more, not only Greece and maybe also Cyprus, but also the rest of the world to make meteorites more famous, and not only for collectors, but more also for educational reasons. Since from my opinion, and this is something that I have also read in books from very popular planetary scientists, meteorites are giving us maybe more or less than 95% of the knowledge about the origin of material in our universe, and of course in our solar system. And this is something that is very important, since the rest is only observational astronomy through telescopes and etc. This, of course, is going maybe to change in the future, but it is as it is at the moment. And meteorites are the only material that we possess and we can examine from very, very close. This is something that's happening that is not easy to participate and to understand by these research topics if you are not maybe in the close cycles of this scientific research. I have to say that we already possess material from Mars, from lunar, from possibly from Mercury, we are not sure. And we are looking for, of course, for samples from Venus and other planetary bodies. And of course, we have already material from meteoroids, asteroids from the main asteroid belt. We have material also from 4 Vesta, that are small planets, minor planets, or planetesimals. And maybe we can also guess that we are able to have in our hands unknown material from unknown protoplanets that in some age 4.5 billion years ago existed in our solar system. Of course, all of this is very interesting, but there is also a holy grail that we don't possess until now. And so far we know, at least. And this is, of course, material for the gas giants of our solar system. That is something that is not possible to do, because our gas giants are made of aerial gases like hydrogen, helium, ammonia, etc. So in order to understand how these gas giants have been created in our solar system, we need possibly to examine material from, or some meteoritic material, if we are lucky, from planets like Mars, in order to understand how this material on Mars have been created and what information can say this material, probably, if we are lucky again, about the formation of Jupiter, Saturn, for example, if any information. For example, by examining some Martian cercotites, we have found, not we, but a team from Zurich with Jason Wu as leader of this team, have found probably a connection to these Martian cercotites with, let's say, the orbit of the kind of orbit that Jupiter and Saturn have had many billion years ago, by the time of their creation and formation. These are very tricky, of course, questions that are not easy to answer, but it is intriguing to try to find informations and data about something like that. So in order to understand as well, the exoplanets have been created by other planetary systems inside our galaxy that we have no information at all. George, I don't know if you can hear me still.
Yes, of course.
Yes.
Okay, because I have not replied from pictures of you.
No, we don't. You didn't share the screen.
I have not shared a screen.
Yes.
I think I had, but
No,
Alexander, can you see the screen?
no, there is no screen yet.
No. Βγαίνεις στο κάτω μέρος, φίλε, που λέει share screen.
yes, I have already.
Πάντα το share. Alexander.
I have already.
Δεν βλέπω τις σειρές. Anyone see the share screen?
No.
No. Δεν το βλέπουμε.
No.
Στο κάτω μέρος του chat,
Ναι.
βλέπεις τα ονόματα, ένα κάτω, εδώ που γράφει τα participants στο chat και στη μέση είναι κίτρινο share screen.
Στο κάτω μέρος του chat, participants, ναι. Μετά έχω share screen, την έχω πατήσει, αλλά I don't see any reaction.
Πατάς εκεί και πρέπει να επιλέξεις το presentation σου.
Αχα.
Και μετά το share.
Okay.
Και θα κάνει approve ο Alexander που είναι πάνω σαν administrator.
Yes.
It is approved.
Just a moment.
Okay, it's approved.
It's approved before we started.
Pre-approved, okay.
You have me now, maybe?
Not yet.
Όχι
yet.
ακόμα.
Maybe now. Maybe now.
Yes, perfect.
Νομίζω, μπράβο, has started sharing screen. Okay, τέλεια. Τέλεια,
Yeah, I will
τέλεια.
put my material again here. I'm not easy to use Zoom very well, so it takes sometimes to have the right material on my screen. And as far now, the internet is not very fast by me at the moment.
Θα το δείξεις από το Facebook ή από το PowerPoint?
Αυτό το PowerPoint θα είναι μάλλον καλύτερα να μπω.
Ναι, κάνε cancel, ξανακάνε stop sharing και ξανακάνε share διαλέγοντας το εικονίδιο.
Δεν ξέρω τώρα πώς θα κάνω stop sharing εδώ πέρα.
Πάλι κάνε κάτω το cursor σου, θα σου βγάλει το stop sharing ή πάνω
Ναι.
στο πάνω μέρος πάλι υπάρχει.
Προσπαθώ να ανοίξω, George, αλλά έχω δυσκολίες με το... ίσως να χρησιμοποιήσουμε ίσως λιγότερες φωτογραφίες για να δω τώρα.
Πρέπει να κάνεις stop sharing. Alexander, can you stop him sharing as an administrator to try to share again the presentation?
Okay, let me try.
I can only stop video here.
Yes, I stopped sharing. Oh no, this will stop. So, and now I'm stop sharing.
Okay.
So we at the beginning.
Στο συγκεκριμένο πρέπει να ανοίξεις το PowerPoint σου και
Ναι.
μετά να μπεις στο πρόγραμμα όταν κάνεις share screen να επιλέξεις το PowerPoint απευθείας και θα το κάνεις share.
Okay, give me 1 minute only. Because, I need to find my files again.
Take your time. So guys, it's been very interesting so far. 95% of the known origins of the material in the solar system came from meteorites and studying them. And I would also like to welcome two very good friends from JPL, Jim Wiggins, and our friend Larry Thaxton, who also hosted us in his house during the solar eclipse 2017. Great to have you here as well, guys.
And as far as I understand, Katie answered so quick that she is not on Mars yet.
Yeah, I'm not on Mars yet. There's not delay.
But you changed the background picture from Mars to Earth, yes?
Yes.
No, I'm still on Mars.
Teletransporting? Well, I cannot see very well.
Yeah.
Okay.
Hang on. At times.
I'm spacewalking, you see.
See, I'm still on Mars.
You're still on Mars, huh?
No.
Teletransportation.
You're answering too quick.
Too quick.
I think I have some progress made here, so I hope I'm soon going to open my PowerPoint presentation.
No, if you want, θέλεις να μου την στείλεις και να την ανοίξω από εδώ, να κάνω share.
Before that, I wanted also to show some material about where meteorites are coming from our solar system. So I'm trying to open now a JPEG only image in order to understand what we have here. And let's see how far I can go with that.
So let me talk about 2 weeks' time. In 2 weeks' time, I'm going to give a talk on the Online Science Café regarding the history of the asteroid day. How did it, where did this idea came from, and how do we celebrate it? How you can participate with your organizations or yourselves. You can be event organizers. We need to share the knowledge, and we also need to share the so-called 100 times declaration, which I'm going to explain in detail later on. It just has to do by sharing technologies and knowledge to increase the awareness, actually, because by doing that, we increase the possibilities and we increase the discoveries of near-Earth objects and more asteroids. And it just happened that last month, some of teams that they were looking for asteroids, they have discovered a supernova in a nearby in a nearby star system. Anyway, I forgot the name. And so you can, while searching for asteroids, you can discover new comets, you can discover new supernova and more. We can share the knowledge with the written if they want, and we can show you how to do citizen science regarding asteroids. And it's really interesting. Every time you open a set and you get data, it's actual NASA research, and you receive your own NASA certificate, official NASA certificates for taking part, and if you make any discoveries, you receive a certificate with your discovery, which is included then in the Minor Planet Center of the International Astronomical Union. And then after we have a confirmed trajectory and we follow it for a certain time, then they get back to you to name it. So it's really interesting, and it's real science actually. So it's interesting, it's intriguing. You become a discoverer by sitting at your home, analyzing images from the biggest telescopes on Earth. So we can share that. And Christaki and John, we're looking for more beautiful astronomical images. Huh? I'm not picking on you, I'm just...
You're looking for more?
I know, I just know who's doing it every night. Έχω φορτωθεί,
Ναι, δώσε μου μισό δευτερόλεπτο γιατί
ναι,
είχα κάποια compatibility
Okay, there is a comment here.
I don't know what's happening with my...
There is a comment here from my friend Christaki. He asked me a message: if a meteorite fell on my property, would I be the owner? I believe, from what I know, but Takis can answer this later on. From what I know, it depends on the country's policy. For example, in other, I know in England, if I'm not mistaken, if they want it, for example, if we find the sample and we take it to the Natural History Museum and they test it, if they want, they can buy it and give you the money if they want to keep it. Otherwise, they will give it back to you and make you an offer if they want to keep it at the museum, but they will test it for free. I've done it 3 or 4 times with different samples, and I've got the certificates here upstairs, and I've done it twice with 2 samples that I got that for me it was obvious that they were igneous rocks from magma, because CYPRUS geology is very important worldwide, and we have a lot of international teams here from Michigan, from England, from Austria. Later we have from Sweden. They are studying the geology of CYPRUS because of our so famous ophiolite main construction of Theodossiou mountains, and many people confuse all the igneous rocks and that came up from the magma with meteorites, because they have crust, they're smooth on the outside. So this is what we call in astronomy meteorite rocks. So next to our meteorites upstairs, we have the meteorite rocks display, and we have similar rocks next to meteorites to compare them. And we have the reports from the Natural History Museum of London that is saying that this is serpentine, this is asbestos, you know. It's really interesting. But we have many reports. We have many people who report to us that they have discovered asteroids meteorites in CYPRUS, but unfortunately, almost every piece we receive is an igneous rock. Oh. And we have a guy that he has found all the meteorites of the world only in a single field in Larnaca area. But it's interesting, you know why? We are laughing, but it's still interesting because we intrigue people into trying to find out about meteorites and science. It doesn't matter if they get it wrong. What matters is that they got into science. Although they were not interested before, they were encouraged, I believe, from our outreach, since they are coming back to us, that they are influenced about outreach, and they got themselves involved into science and meteorites, especially.
George, I had some compatibility issues with my PowerPoints and my iMac. Now I'm ready to start, finally.
Okay,
I'm sorry for the delay.
no worries. Next break I will sing.
Okay, so you can share if you want now my screen
Yes,
in order to show you some material
Yes.
that I have prepared here for.
Okay, πήγαινε στο κάτω μέρος και βάλα το share και είσαι ok. Αλλά επέλεξε το εικονίδιο του PowerPoint.
Κάτω μέρος share. Okay.
Και βλέπεις όλα τα Windows που είναι ανοιχτά.
Ναι. Πιστεύω τώρα θα ίσως να με βλέπετε.
It's prepared. Yes, perfect. Now we have picture.
Okay.
Great. So my first slide here is about the different asteroid types and meteorite types that we have already here discovered on our planets. And this is very important to make a very short introduction to that material, because if you start with the main asteroid belt and the samples that are traveling to us from there as small meteoroids or bigger asteroids, then we have to separate the chondritic material, the ordinary chondrites that we found here as meteoritic material, that comes mainly from meteoroids and asteroids that are, of course, small or bigger rocks, celestial bodies that are orbiting our solar system. And if we find in our planet meteoritic iron, then we are talking for sure for material from the protoplanets of our solar system, and especially from the cores of destroyed protoplanets, some 4.5 billion years ago again. So these are where the iron meteorites are coming from. And here we have mainly the asteroid type M that we are observing as asteroids in the main asteroid belt. This is where the iron meteorites are mainly coming from to us. According to the same topic here, chondritic material, stony meteorites of ordinary chondrites are coming mainly from asteroids of type C. Now, if we are talking about stony iron meteorites like pallasites or mesosideриtes, then we are talking again from very rare material that once existed in the inner mantle or the outer core of, again, protoplanets or minor planets of our solar system many billion years before. And last, I'm going to mention, of course, the achondritic meteorites, the achondrites, and the achondritic stony material are coming mainly from asteroids of type S, where S is here for stony. This material is mainly planetary material. It's very, very rare. It's only about 2.5% of all meteorites that have been found in our planet. And mainly when we are talking about achondrites, we are talking about Martian meteorites, lunar meteorites, and meteorites from 4 Vesta. So, according to this schema, the chondritic material, the chondritic stony meteorites are making more than maybe 70 to 80% of the ore found in as meteoritic material in our planet, and the rest are making the irons and the stony irons, of course, like the pallasites and the mesosideриtes, with another 2.5% about. approximately. So I believe now we have a first theme of how the meteoritic material is compared to the main asteroid bodies on the main asteroid belt. What I have not forgotten to mention, but I want to close this topic now, is about the cometary material and the cometary meteorite material that we are finding very, very rare in our planets. Here we are talking mainly about Carbonaceous Chondrites. This is a subcategory of the stony meteorites and the Achondritic Meteorites. The Carbonaceous Chondrites is the material actually that have helped in order to our sun to be created, or star to be created. As the Achondritic material have also helped in order to create our rocky planets, Mercury, Venus, Earth, and Mars, mainly. So all this material, as you understand now, is very, very important in order to find the origins of the creation of our planets. All this material, especially now the carbonaceous chondrites and the ordinary chondrites, are the first material that have been created in our protoplanetary disk, from which one the proto-sun or sun later, and the protoplanets, many dozens of protoplanets have been created before the final form and creation of the 8 planets that we already known in our solar system took place. So it was going on in a very, I would like to say, very not friendly process during the very first 10, 20, or 30 million of years after the creation of our protoplanets in our solar system. Here exactly it was taking place, as the astronomers are calling it, a cosmic billiard between the first protoplanets, where the biggest celestial bodies, the biggest protoplanets, have been smashing with the smaller ones and integrated the smaller ones as a new unique body. By this material, we believe that our planet Earth have needed about more than 10 or maybe 12 protoplanets to integrate as planetary material before being taking the size that we already possess today as planet. By the same process, Venus have probably needed 7 protoplanets in order to have the initial mass that have today. That is about 0.7 the mass of our planet Earth. This is some examples now said only here in order to understand the violent process that took place by the first 20, 30, or maybe 50 million years after the creation of our sun and the protoplanets in our solar system. So all this meteoritic material provide us with necessary informations about what was happening before our creation. And this is so important because we have no other direct source to examine or to observe directly what is happening in other exoplanetary solar systems in our galaxy. This is a process that can take place many million and 10 of millions of years. And by investigating, examining meteoritic material, we have everything close together, a history of many million, if not billion of years, at maybe 1 or some dozen of stones found by our planets. So this is why I believe that the research and the investigation of nowadays still for many planetary institutes take place, and we are able to help them to find the right material to examine. As also, of course, as IMCA member, we are interested to make our own collections and to search for our new meteorites worldwide. George, I hope that everything is okay there, and we'll ask if there are any questions about what I'm talking about here.
Is there any chance to receive meteorites from extra solar system objects?
Okay, this is a very interesting approach and a very interesting question. I have been asked before many times. This is a possibility. As far as I know, there is probably at least one meteorite found in Egypt that has accidentally or not an ancient Greek name, the name of a Greek woman astronomer, Hypatia is the name of this meteorite, that have been found accidentally as very small fragments, a few grams, and as now examined by the University, I think, of Johannesburg in South Africa. We believe that this material have nothing to do with our solar system, and is the most likely case of exoplanetary material existing by meteorites that we have already found in our planet. This was accidentally found some years before. We don't have so many informations in public about this meteoritic material. So if you want to get many more information about Hypatia meteorite, you have to ask the University of Johannesburg, I'm afraid.
No, the question is how it is discovered. It could be due to dating. You may, based on the material, you may find out the date. And if it is more than 4.5 billion years, then it's definitely not from solar system.
Yes.
So maybe that's the way how it is reconstructed.
Not only, there are many ways to categorize meteoritic material as possible, not from our planetary system. The first one is by observing this material falling down on Earth, nowadays with sonars, telescopes, etc. Luckily that it came some weeks before in Australia. We have had a meteorite fall in Australia that have we observed the trajectory of the meteorite. And there are only two possibilities for this one in Australia. That the one is that it's a Martian meteorite, if we found it. And the other one is that probably came outside from our solar system. Here, the main facts are the velocity of this meteoroid that was very fast traveling, not possibly from inner solar system meteoritic material. And the second was, of course, the projection, let's say, the place, the trajectory of a meteorite that came inside our atmosphere. So this is a very well now known case that is a possibility. Now, about the age, yes, I have to say that even by known meteorites falling down here on Earth, like by Carbonaceous Chondrites, we can find inside them inclusions that are from the days before our solar system. Since our solar system has been created from remnants, the material of a supernova explosion some million of years before the creation of our sun and our planetary system. We can find inside carbonaceous chondrites, like of the category or subcategory of CV3 or CM1 and 2, inclusions that, like the CIs named, CIs means calcium aluminum inclusions that are remnants from supernova explosions. So even by inner system meteorites, we can find material that have their origin from outside our solar system. And this is somehow already amazing. But of course, we are open to any possible new discoveries. Of course, it's not always possible to understand this discovery before have been to the lab and examined from different laboratories, from different planetary institutes around the world. The first or another, let's say, interesting topic is to examine the crystallic structure and the minerals inside the meteorite. So I think I have covered more or less the main facts that we are examining for a possible meteoritic material that comes, let's say, we suggest that could come outside our solar system. But of course, the age, if we can examine also radioactive elements inside the meteorite, or we can examine the oxygen isotopes, like oxygen 16, 17, 18, we can give the identity of a Martian meteorite, a lunar meteorite, a meteorite from Mercury, or any other planetary body of our solar system. Here the fact is again that we have first to have been there, to be on the moon, to be on Mars, to be on Mercury, in order to give the exactly identity and recognition that this meteorite, according to the isotopic analysis, is coming from planet Mars or from the moon. So this is an important fact that first we have to examine rocks on the surface of the planet, and then we can compare it with meteoritic material. This is the easy way, let's say. George, I don't know, Oleg, if there are any questions here, any
I have another one.
okay.
Are you expecting to learn something from the Osiris mission, returning the samples of asteroids that will help with your studies of meteorites?
Yes, like Hayabusa by the Japanese side, we're also expecting here this moment that Osiris will bring down on Earth this very precious material. I dare to say that we probably already own similar material from meteoritic material that is falling here down on our planet. But I'm sure, definitely sure, we will find very interesting things inside Osiris samples. So there are many different sides of this material that have to be examined. One is also, of course, to compare, in order to compare with well-known other asteroids in our solar system, as also with very well-known subcategories of maybe carbonaceous chondrites that have fallen here down on Earth, and we already have examined many of them. So we are looking forward. Now, if there are any other questions about the same topic, otherwise I would like, if I have 10 minutes more, we have time. George, I don't know how it
Yes,
is.
welcome.
I will try to open my PowerPoint again. There is someone here, I believe here, yes. And I will try, of course, to show you, if I have the right PowerPoint here, that meteoritic craters or craters from meteoritic origin are everywhere in our solar system. And the very first crater that have been, I'm sorry, I have to go back. Here we are. The very first meteoritic crater that have been recognized in the 20th century was, of course, the famous Beringer crater or the Canyon Diablo crater, according to a meteoritic material that have been found there. It is a crater that is created from the iron meteorite that have fallen about approximately 50,000 years before, in Arizona, in the region of Coconino, Arizona. Until then, we have found and recognized about something more than 200 meteoritic craters of meteoritic origin in our planet. My personal research, of course, has to do mainly with my country, Greece, and the twin Zerelia lake craters that are situated near the small town of Almiros in Thessaly. My research there have started some 13 years before with a small team, also mainly from students of mine of the Platos Academy from the University of Athens. And by the first years of our research, we have found mainly nothing. I was really wondering if I have chosen the right place to start my research in Greece, together with some other places, of course, simultaneously. But I consisted and I came back there again and again by studying better the geomorphology of the twin lakes. We finally, in the years 2012 and 2013, we started to discover some very interesting material after some years of research. Of course, we have had first clues about the meteoritic origin, as we have discovered the years before the 2012 some possible impactites and impact material all around the twin lakes, the Zerelia lakes. But without finding any meteoritic material, we could not be safe for our discoveries. We could not be sure of the origin of the Zerelia lakes. So by the year 2012, first, we have starting to believing to have found some material that have to do with the two small asteroid faults there. This was also the reason that 3 years later, a very well-known planetary scientist came to visit me in Athens. Tony Irving have been, let's say, interested about my founds, and we have started together with other planetary geologists from the University of North Arizona, like Ted Vance, to examine more and more samples from impact origin or from possible meteoritic origin from the twin lakes in Zerelia. Many years have passed until then. Also, the last 2 years were not very productive during the COVID pandemic, but we are trying always to examine new samples by laboratories, like by the Polytechnical University of Athens with Professor Ilias Theodoridis, who has also participated in my research in Zerelia. So the difficult thing by this case, and I'll make it short now, is that we don't believe that we have only a very simple fall of meteoritic material and high possible of iron meteorites there, and the creation of two craters, some maybe 12,000 years before. But because of the location of the Zerera lakes, that is a region that is populated for many, many thousands of years of the ancient Greek folks like the Pelasgi and Myrmidons. That is a region that is very well populated for thousands of years. At least we know that from 5,800 BC, this region was high populated. So, in my opinion, from our founds, any meteoritic material, iron meteorite that have been found there, have been used according to our founds in order to be created in the past tools, weapons, and other artifacts from meteoritic iron. This is nothing new. According to many studies from planetary geologists, we already know that Pharaoh Tutankhamun possesses two small knives from meteoritic iron. The Polish people have also been using probably meteoritic iron until the 8,000 BC. In North and Central America is the same situation. So now was time, I believe, that we have finally found the first clues that the ancient Greeks, especially the Myrmidons, the very famous folk of Achilles, have been probably using meteoritic iron in order to create a mix of steel that have been probably a super weapon, let's say, for their time. These clues are coming now from our founds, like high percent of nickel, a percent of 6, 7, and 9% is some samples of artifacts, as also of iridium in samples of iron samples that we have found around the lakes of Zerelia. The iridium have been found on a laboratory in Colorado by Richard Kunter, a member also of IMCA, that is also cooperating, as far as I know, also with NASA. Nickel percent have been found for the first time by the laboratory of the Metsovion University of Athens, by the metallurgical department, again by Professor Elias Hatzitheodoridis. But in order to close this case finally and date our founds, that we are trying now to prove that everything happened in the past and not that I throw there some meteoritic material and melt it in order to create weapons, we need to date our finds. And to date iron is almost impossible. So we have been trying now to date our finds indirectly by the way they have been creating this material using carbon and other minerals. Carbon here is going to take a very important place by our next year research. If we manage to date carbon, I believe we are close to the date of 10th century BC. So we will be only 2 centuries ago from the era of Achilles. And who knows, maybe we are going to go back also to achieve the 12th century BC. We don't know yet. So this is so far about our research in Zerelia lakes. I'll make it short. And hopefully it was easy to follow me here somehow. Of course, our research is still going on. We still need money to examine again and again new samples, and in order to testify not only once, but twice and 3 times the same results by different planetary institutions in order to bring them and publish our scientific paper. So I don't know if you have any questions here.
George, you are not mute.
I will be happy if everybody understood me somehow with my English.
It's perfect.
That's good.
So for any case, it's a very long research, and that's because we are not so lucky to have been found the original meteoritic material, but what we have found is a melted meteoritic iron, high probably, melted by furnace by the ancient Greeks. So in order to testify something like that, it takes time and new finds and money, of course, a lot of amount of money. This is a very, very difficult case.
Especially money is something that is very rare in our days.
Yes, and it moves the world and it moves also science, scientific research.
And believe me, I know your passion about this discovery since the first minute we met, and you talked to me about this discovery you're trying to make in those lakes. And I'm really proud of you because you insisted, because you felt that there is something there, and you tried over and over through the years until you managed to prove something. And I wish you all the best, and I would like to congratulate you again for this initiative to insist, and with using your knowledge and experience, that you're trying to prove this. And I believe, from what I know from our previous talks, you're very close to prove and very close to your scientific paper. I wish you all the best.
Thank you, George. Let's hope so too.
But I want a promise. You have to take me to these lakes one day.
This is what we are planning already with the municipality of Almiros and the mayor there. We were planning last year a 2030 international conference.
I remember.
Near the lakes, there is an exhibitional center already constructed with cafeteria and other facilities that would be perfect match to organize an international symposium there. Unfortunately, now we have to wait 1 or 2 years, maybe more, let's say. But this is also good because maybe then we will have more results, and maybe we will have already published our scientific paper in a famous planetary magazine, and they will have more things to show to the public and to the participants, for sure.
Any questions regarding this research?
I'm not sure if I have here now the picture of the Zerelia lakes here, according to my presentations. I'm sorry for that. It was my mistake. I had some problems with the compatibility of my PowerPoints today. I don't know why. Here. Let me have here the Zerelia lakes, the small lake, and here are some material, here are some impact material that have been found on the lakes by my team. impact backfall breccias here mainly, here and here, and some other material, probably impact tides that have been also used in order to construct ancient bricks or walls or whatever. We don't know exactly. No, here this is not what I'm. And here are some other also artifacts. I'm sorry, somehow it's moving from alone, my participant. Here are some other material that we have found also near the lakes by our excavations, very deep. This is probably an iron artifact here on the upstairs in the middle, but still are moving. I'm sorry for that. So here again, this is an iron artifact in the middle that contains as well some high nickel percent, but everything this has to be examined. This was probably a small knife or something made from iron, and probably meteoritic iron, we believe. Also here, other material that have to be examined.
Takis, the picture on the left to the one you just described, is it a conglomerate or it's just a cross section of the?
This is impact backfall breccias mainly, George. Let me show you again here. That are not meteoritics, that are impactites, let's say, possible impactites. I say possible because so far as we have not finished our examinations, the approval of the twin lakes as meteoritic craters, I say possible. I am sure, almost sure, that is impact backfall breccias here that contains inside different xenomorphic and parts of material from around the lake that have been molten inside a matrix, created a totally new mineral and stones that we are calling impactites, let's say.
Mm-hmm. We have a question from Christagi here. How much real international cooperation is there when meteorites are discovered?
That's a good question. It depends always from the case. And
and we have the latest case that we talked about last week, remember?
Yes.
That's been examined from the University of
So everybody is trying to approach important scientists, and if you manage to wake up the gear of these people, then you have it probably easier sometimes. But you have to have the facts usually at once here, that because everybody is having a lot of work to do, and even if we managed here to bring Tony Irving some 5 years before, this doesn't mean that Tony Irving will be always available for that. So it depends of your personal connections mainly. Some people will be going to help you, some people probably will be against you if it comes in order to sell your material or to try to bring something that they have not managed by themselves to discover. And this is happening also by the academic community as well.
Yes.
So it's a jungle out there, let's say.
So, for instance, the material that fell in the UK, was it Gloucestershire, I think, recently? Where, you know, how sort of
to whom it
willing
belongs.
are they to let you know, to let the rest of the world see it, or is it going to be owned by the British Museum or the, you know, who will effectively take ownership of that?
That's a good question, Mr. Christaki. It depends everything from where you found this material. If you and according to the laws of every country, sometimes it's different. For example, countries like Australia or Canada or Oman, they are not allowing you to hold for yourself any meteorite finds. You are not allowed to possess them, probably. Or you are maybe going to allow you to possess them, but you cannot export them to other institutions worldwide. You need the special papers. Other countries left the handle of meteorites for free. But even here, your finds must be made by public place and not by the private property of the owner of somebody's land. So if you find a meteorite by somebody's land, you have first to take his personal approval in order to search for meteorites in his property. So there are many different laws and bylaws that every single region or country, you must be aware of them before going to search for meteorites.
But once discovered, and let's say it's in the UK, and it goes to the university, or who would it be the museum, the British Museum, or is there a particular organisation that would be interested in it? And then having got that information, how willing are they to say, share it with anyone else?
Yes, if we are talking for a new meteorite find, then for sure, definitely you need to make the final approval through an IMCA member or through a professor of a planetary institute through the Meteoritical Society. We personally have more easy access there, but everybody can have potentially access there and recognize his meteorite find if it is if we are talking about a new meteorite find.
And then how willing are they to share the findings with other people or with other?
Yes, this will be published. This will be published, Mr. Christakis, through Meteoritical Bulletin, through the Meteoritical Planetary Magazine, by official papers, also by our Time magazine by IMCA. Since IMCA and Meteoritical Society are two aspects of the same coin, we are both working in cooperation in order to proceed with new meteorite finds. For example, if a meteorite hunter finds a new meteorite in a public place, this is the process he's going to follow in order to make his meteorite find official.
Okay, thank you.
Can I show you something? My wife found this in the bottom of the garden last year during the lockdown.
Oh.
It looks very much like what you can describe as chondritic stony meteorite asteroid C.
It looks interesting, but I need to have a bigger picture. I'm trying now to put my PowerPoint in order probably to have a better.
Yeah. It has some tiny little bits of glitter in it as well.
It looks earthy.
But in your very first slide on the left-hand side, it showed something that looked exactly like this, even broken up the same way.
If it would be a meteorite, this one can be only a carbonaceous chondrite. That is a very rare material.
Yes.
And would be very interesting. Can you show me, please, another time the back side?
Yeah.
Because, yes.
Yes, it's just rounded off.
Yes. Since it's moving, I cannot have a very close, good approach. But what you have to do next is probably to open a better window and to polish this window. And if you are interested, I can examine the picture of this one for free for you and tell you if it is something that will be interesting to be sent by a planetary institution for further research.
So, so if I take photographs of it and send them to you, you'll be able to identify
please.
it. I'll do that.
I'll be glad to help you. My first impression is probably...
very much. So will you give us an address at the end?
I worry a bit about
Sorry,
the
frozen.
cavities. Takis, I worry
Yes.
a bit about the cavities, the holes.
I cannot see very good the stone because it was moving.
Ash,
And-
Mr. Ash, can you move a bit backwards so that we be better focused? Let me double click and.
I'll tilt it up towards the light a bit.
Yes, it sounds interesting, but without having a polished window, it will be very difficult to say from the video now.
Yeah,
It can be a typical earth rock, but it can be something very rare, like a carbonaceous chondrite, a primitive carbonaceous chondrite.
carbonaceous chondrite.
A bit backwards. Can you keep it a bit further?
Oh, I'm
away?
sorry, you want to see it again?
Yes, keep it
Yeah.
there, Ash. A bit, no, further back. Keep it there for
Hang on.
It's focused there.
What you have to do, if you have the ability, is
It's not a crystal. It's
to
like
polish the one side that is open now, that is broken. The
Yeah,
broken
that's where
side,
it's broken.
Yeah.
the broken side has to be polished,
The
if
cross
possible, in order to have a better view of
Yes.
the window. So then I can tell you for sure if it is something
Yes.
interesting to be examined further or not.
So it would be safe to polish it, would it?
Yeah.
Yes, yes.
Because
Not
I
lose
didn't
a
want-
little bit material, but it is necessarily in order to have an opinion.
I don't know if I have the equipment to do that. Yeah,
Of course, you have to be careful by polishing this. If you know how to use some polishing material,
yes,
polishing wheels, have to be very careful.
yes. Hmm. Yes, it was under the ground. It was on an area that had been prepared for planting, and it had weed suppressant material down, and then there it was, just lying on the top of this. So it hadn't been dug up or anything.
It's quite interesting. I will be glad if I can help somehow. Let's keep that way. Maybe something totally usual, but maybe less small sands. Maybe that is something unusual,
Yes,
like a rare
yes.
carbonaceous chondrite.
Right. So it's carbonaceous chondrite.
For the best case, yes. If you are,
My wife will be overjoyed.
Don't tell her. Sell it and get the money for vacation.
Right. Thank you.
you're welcome.
Any more questions?
Yes, we have question from Katie Dimitriou. Katie, welcome.
Okay, yes.
Does anyone know?
They've changed lately, Katie. The question was that, does anyone know the rules of the CYPRUS government about the meteorite find? Okay. Before you used to catch it, now they don't allow you even to collect stones, rock, or fossils, and excavation is forbidden.
I think I'm unmuted now.
Yes,
Yeah,
you're okay.
Yeah, I had a feeling because of the strict rules about the archaeological finds that maybe it would match something like this here in Cyprus. So, okay, thank you.
Welcome.
May I answer to Mrs. Dimitriou?
Yeah.
Yes, according to my knowledge, of course, countries like Cyprus and Greece, we have a very big problem. We are not allowed, of course, we're never going to search for meteorites or for meteoritic material inside archaeological places. Only if you get a very private permission of the Ministry of Culture or of the archaeological department, etc. This is a very unlikely situation, especially in Greece and Cyprus, because I'm sure that the ancient Greeks, they have not only know more things about meteorites, but they have been also keeping meteorites in very famous places, like the famous omphalos of Delphi, we really believe that was possibly iron meteorite of conical shape, and was kept close to Pythia on the Temple of Apollon in Delphi. This is also the logo for collection, the aerolith collection, of course. The god Apollon sitting on the omphalos. So we are unlucky here not to have the possibility to search all over the area of our country.
Yeah, it would be really interesting if there has been research on Cypriot artifacts, metallic artifacts. I have no idea personally. If anyone has researched it, the collections here.
So far I know, I have mentioned once in my books, in my book about meteoritics and meteorites in Greek language, about a case in Cyprus. In Paphos, there is a possibility. There have been also the pictures by ancient Greek coins of the temple of Aphrodite, that the holy stone there was probably from meteoritic origin, but we are not sure.
I have visited it with some astronomers.
Yes.
And it's actually magmatic. It's igneous rock.
I also tend to believe this.
And we realized that, you know why? Because when the people were touching it, it's also called, it was also called the black stone, like the one on Palos, and like the one in Mecca. And we searched it because it's kind of, you know, it has the shape, this aerodynamic shape on the top, but nobody was actually moving it. And okay, I shouldn't tell this now live, but I had the opportunity to check it at a place where the people were not touching it usually, and check that cross section. And there was findings that it proves it was an igneous rock, but because people were touching it all the time, it became so smooth and aerodynamic on the outside. I took the pictures and also had the pictures of the cross section at the bottom, and I can forward them to you. But there is another one, which is actually meteorite, and it's the one that was found in Takis in Larnaca. And the myth says that the auntie of Muhammad, I know everybody's going to Google it now, but the auntie of Muhammad, Mecca and Medina, when they were living on the donkey, a big fire from the sky, the god sent a big fire from the sky and killed them. And this is a place where we have the salt lakes now in Larnaca, opposite to the airport. And there are also many researchers that also visited Cyprus, especially with that rock, and they used to, and they also thought of it as being a meteorite. And but the myth also suggests that it fell from the sky.
This is not exactly, George. If you allow me to say, because I have also studied this Mecca stone, we don't believe that it's a meteorite.
Not the Mecca stone.
Sorry.
I'm talking about the one in Takis, in Cyprus.
This one?
Yes.
Okay. I have no idea about this so far.
I mentioned the Mecca stone because they also call it black stone, like the Omphalos. But they believed that it was a meteorite. I'm not sure about that. Is that one a meteorite as well? The one in Mecca?
The Mecca is not a meteorite, in my opinion, no. But there is probably a connection that I'm mentioning in my book. You can find it in the first chapter. But still we don't know. For sure there is not a meteorite, in my opinion, and the opinion of other scientific researchers. But according now to the omphalos, I have to say only one thing, George, that these conical shaped stones have the usual thumbprints that is typical only for meteorites. As also the description that we have from the ancient Greek historians, everything looks meteoritic, but we cannot prove it since we don't have found this holy material, holy stone. It is lost by time. Now about the K, this is very interesting case. I would like to see pictures if you have any.
Yes, these two are the most famous in Cyprus: the Aphrodite sanctuary stone and the Takis.
I have here also for another case about Cyprus, if you allow me to mention here. But this has to do with probably military stuff. And by the time the English military have had bases on the island of Cyprus,
yes,
there is a possibility that something can be found on the mountains.
I found a crater also there. Anyway.
But everything, this is rumors, everything. So I cannot say now. Nothing before examining the samples or the material, if we have found something. So if you have something from Takis, you can send me, of course, pictures. I can tell you my opinion.
They've hid it under a piece of cloth, and when I asked the Hoja, who is in charge of the place, he said that they believe that it was levitating, and then they put it down to rest. So this was his answer.
Okay, interesting. So you have now not access anymore to this?
Of course I have access, but not to the direct stone. It's been covered by the cloth, and it's on top of the tomb of Medina. And it's very high, you cannot reach it.
Okay.
I will try to go officially.
Yeah, it would be better.
Yes, yes. And because I'm also studying the lakes there around. We'll see. Actually, next to it, the area of the lakes, the Swedish archaeologists are there. They are investigating the area. And in a depth of 20 centimeters, 30 centimeters, they found 3 different, not civilizations, but 3 different settlements.
Okay.
And one of the settlements, it seems that it has died unexpectedly from physical reasons, from natural reasons. It is believed to be from a tsunami from Crete that reached that, or from the tsunami in Greece from the Santorini. That was placed by Santorini. And there was another tsunami that I discussed with Dr. Moussas of the astrophysicist. That took place later on in Crete, and I watched that on Discovery as well. Maybe that wave reached and destroyed these settlements. The other one, there was a lot of burns, so the settlements were burnt, and the other one was abandoned. So this is very different one to each other. I mean, the situation that the settlements were found. I mean, usually during a war, you find killed people from, I don't know, from arrows. From in one case, they found the workshop of someone who was I don't know, he was dealing with iron, or he was dealing with something I don't remember. And they found the tools there, and he died while he was working. So this means that there was a natural disaster.
Yes, interesting.
Any more questions to our guest speaker?
Yeah, I asked them. I put one down. Does a meteor have to be of a certain size, or shape, or density, or something else before it can actually fall as a meteorite? Or does the bigger it is, the more it burns up? Or, you know, what determines whether a meteorite falls rather than burns up as a meteor, is my question. Sorry, making myself that clear.
Yes, yes, Mrs. Christakis, it must be every meteor or meteoroid must have a critical size in order to survive the pass through the Earth atmosphere, and in order to not get burnt the whole sample, and in order to fall down and we found it as a meteorite. Only then we can say we have a meteorite. So if we are talking about shooting stars, we are talking about meteors mainly that are only very small, teeny grains, like the grains of, how to say, on the beach, where we are walking. Yes, teeny, weeny grains of sand, exactly. So these ones are burning in milliseconds. That's why you never make any wish by shooting stars. Now, in order to have the right critical mass and to survive the pass through the Earth atmosphere, that will be at least about approximately 100 kilometers traveling inside the Earth atmosphere before falling down as free falling. A meteoroid will lose approximately 60% of his mass. So now, then if you found a meteorite, then you can probably I say, calculate the main mass. But even then, there are other restrictions and other facts you have to follow through the fall. If, for example, the meteoroid is going to break on the atmosphere, then you have, and you find one piece, there maybe are still another 100 pieces to find in the area, in the same area, some kilometers away. But so far from what we know, every meteoroid or asteroid, small asteroid, is, if it is made of stony material and not a meteorite, is losing about approximately 60% of his initial mass.
Okay. Okay. And does the angle of descent or the speed or have a factor as well? Or
yes, but this is something that we cannot say now. But each situation is different. The angle, the speed, and the material are three main factors that we are using in order to categorize a meteoritic material that can be found on Earth, and the loss inside the atmosphere as well. So the angle is more important, of course, if you see by the meteorite that you have found a specific orientation by the shape. That's why some meteorites have conical shapes, or they have a shape of a shield. They are very beautiful, or they are formed, let's say. They are oriented, we say that in our language. An oriented meteorite is a very collective one, since mainly a meteorite, even it breaks in more parts inside the atmosphere before falling down on Earth, or is having a trajectory and a falling down, free falling after, that creates unusual and irregular shapes. Of course, the shape of the same celestial body, the same celestial rock, before entering our atmosphere, is a irregular one, usually.
Okay. Interesting. Thank you.
And one more question. Okay, thank you, Takis, for your excellent talk. Thank you very much.
Thank
And
you.
I wanted to mention what we will have next. It's for young generation. We already mentioned it. We'll start for small children at our planetarium Zoom meetings again online. So it will be in English, so not obligatory from Cyprus. People could join us. The person should be 8-12 years old, and then we will study wonderful planets, not only 8 planets of the solar system, but all over the world. And next time, on the 8th of June, everyone is welcome to our online science cafe. This time we'll talk about the history of Asteroid Day, how it happened, and the origin of it is obviously Tunguska meteorite, or let's say Tunguska event, which was in 1908. So
This is very interesting.
everyone is welcome.
Thank you.
So I just wanted to remind you that we will shift the time 1 hour later. So to fulfill all our, the needs of our English friends. So instead of holding it 7 o'clock Cyprus time, 8 o'clock Cyprus time, which is 2 hour difference, so 6 o'clock English time. UTC +3.
Thank you very much.
Just to show your respect for your support and for your support and for the good friendship and affiliation all those years.
Thanks a lot. Very nice. Good night to all.
Good night.
Thank you very much, Mandarin. Alec, спасибо, что пришел.
Thank you very much.
Thank you
Thank you very much. Andy,
Увидимся. До свидания.
Okay, bye everyone.
Γεια σας, παιδιά. Ευχαριστούμε πολύ. Host Terry, thank you very much. Roy, μου ευχαριστούμε πολύ.
Και εγώ ευχαριστώ.
Γεια μου, ευχαριστώ. Μπήκε στο Ερμάν, μόλις είσαι έτοιμος, είμαστε έτοιμοι.
ευχαριστώ.
Καλή νύχτα.
Ευχαριστώ.